Hello everybody, this is the fourth clip of our chapter 3, and this clip is all about the so-called cross product, okay, or sometimes we use the word vector product, because now your vector A cross vector B becomes another vector, okay, and this vector is the vector that is perpendicular or orthogonal to both A and B. Okay, so it is another vector. Okay, and this vector is perpendicular to both A and B. So for example, if here's the A, there's the B, then the A cross B will be look like that. Okay, so we know the direction. This one is perpendicular to both of them. Okay, and the direction of A cross B will be the one that obey the right hand law, is what you have learned in physics. Okay, so in math, to find the A cross B, we can use this formula. However, to me, I really cannot remember this formula, but we are going to find it using the determinant. Okay, we are going to find using the determinant, and the determinant will be the one that consists of the first row as ijk, the second row as a component of A, and the third row as a component of B. Okay, and hopefully you know how to find a determinant of the 3x3 matrices. So this one you can write down another two column, A1, A2, and B1, B2, and what you are going to do is to multiply it until you get 3 terms. Okay, so you do the multiply downward just like this, 3 of them. So as you multiply downward, the sign will be positive, so it means that your sign will not change, okay, according to this multiplication. If you got positive, then you have positive. If you got negative, then you have negative. But if you do the upward multiplication, okay, your sign will indicate by negative. So it means that as you get your product, or as you get your multiplication, you change the sign of the result. Okay, after that you are going to add them up together to get your determinant. Okay, but to add them up, it depends on the I and the J, okay, and the K, all right, as a vector. So as we continue for our example, then you see all numerical example. So what does this mean? It means that, I mean, if we do it this way, your I, your J, and your K, and then you find the cross product between the same vector, A1, A2, A3, A1, A2, A3. So by using the knowledge of determinant, if you got two row which has the same element, then the determinant always 0. So it means that your A cross A becomes a 0, but don't forget that this time it is a cross product or a vector product. So the 0 that we're talking about, it is a 0 vector. Okay, so you got all 0, 0, 0, okay, in each of the component. And we got some theorem, okay, about the cross product. Okay, the first one is that the vector, so this is the new vector, okay, A cross B, it is the one that orthogonal to both A and B. The second theorem that we would like to share with you is that the length, okay, this one is only the length of A cross B. It is the length of A, the length of B, and side theta, where theta is the small angle between A and B. So don't forget that now the angle between A and B arise into two product of vector already. One of them is a dot b, which is the length of a, the length of b, and cosine theta. The other one now is the sine theta, depends on the cross product, but don't forget that this one you're talking about the length only, okay? And because of the sine theta, we know that two vectors are parallel to each other if your a cross b becomes 0. Why is that? Because if it is parallel to each other, sometimes it go like this, right? So the angle between them is 0, but sometimes it may go like that. So the angle between them is pi. So either side of 0 or side of pi, they are all 0. So if they are parallel, then the cross product is 0. Not like what we have before, that if they are perpendicular, then your dot product, it is 0. Okay, and the length of the cross product is equal to the area of a parallelogram determined by these two vectors. So what does this mean? If you got one leg of one side of the parallelogram as the A, the other side as the B, so here is also the length of B, there is also the length of A. So to find this area, don't forget that the area depends on the base, the length of the base multiply the height. Okay, let's say that this one is the angle theta. So your h, okay, your h as the height, okay, over the length of A. What is it? The h now is the opposite of the angle theta, and the A is the hypotenuse. So this one is actually your sine of the angle theta. So it means that your h is the length of A sine theta. So to find the area, okay, let's say that this is the area A of the parallelogram. It is the base multiply the height. So it is the A sine theta, and then multiply by the length of B, which is the same as the magnitude or the length of A cross B. Okay, so the area is the A cross B. Of course, I mean, if you want to find only half of them, okay, so this kind of area, the area of the triangle, okay, determined by the two legs A and B like this, it just simply the what, half of the area. So the one over here is half of the area of the parallelogram. So it's the same as A cross B, find magnitude and divided by 2. Okay, we get the, do we need to write down for you? So let us write down for you using the green one. So the area of the triangle, okay, determined by A and B, it is 1/2 of the magnitude of A cross B, okay, because of that green area. All right, okay. Oh, that's the first problem that we are going to find. Okay, so let's look at the first problem. It's saying that you want to find the area of the triangle with these 3 vertices. Okay, so let us call this is a P, and then go to a Q, and then go to a R. Okay, so what we have to find is a PQ, which is again Q minus P, don't forget. So your Q is -2, your P is 1, it's 5 and 4, and then -1 and 6. So you got -3, 1, -7. Okay, how about your PR? as indicated in the picture, your PR is R minus P, so your R is 1 minus P is 1, and then negative 1 and 4 and 1 minus 6. So you got first step is 0, 5 and 5. Okay, negative 5 and negative 5. All right. So to find the area of a triangle, it is this one, right? 1/2 of A cross B. Find the magnitude. So you are going to find the A cross B first. Okay. I mean, of course, you can find some other way. For example, you may say that, hey, we want to find the theta, and then using the formula with the length of A, length of B, and sine theta. Okay, you can find that way as well. But to find the theta, it would be better for you to find the cos theta using a dot product, because that one will be the easier way. Okay. However, this one, because we want you guys to practice on how to find the cross product. So let us doing this problem using a cross product between these two vectors. So the cross product will start with ijk, and then the pq, which is -3, 1, -7, and the pr, which is 0, -5, -5. Okay. So if you are so good, then you may have a quick way to find the determinant. Okay. However, let us just do it slow. Okay, I mean the quick way is that you can see this -5 and you can pull it out and all that kind of thing. Okay, but let us do the slow way, just like this. So you do a multiply here for the first diagonal. So you have -5i. Okay, and then the second diagonal, you got a 0j, so I going to just don't write down. And then the last diagonal multiply, you got a 15k. Okay, so as I told you, when you do it downward, okay, what you get, you just let it like that. Okay, you don't need to change anything. However, if you do it upward, okay, so for example, this one is 0, so it's nothing to change, right? But this one, you got 35i. Instead of putting 35, you have -35i, just like this. And then the last one is a j. So actually you got 15j as a positive. Then you plug in -15j, and then you just add them up to end up with your I is 40, your j is 15, and your k is 15 as well. Okay, so it's -14, -15, and 15. This is the cross product. Next, you are going to find the magnitude or the length of the cross product. So it is a square root of let's see, -40 square, -15 square, and also a 50 square. Okay, so it again depends on how good your algebra is. If your algebra are so good, then you may like pull out the 5 from each of the component, and then the calculation will be a lot easier. Okay, so this is a square root of 1600s, and 225 and 225. Okay, so you have 450. So you got a square root of 2050. Okay, and the area of the triangle, it just simply 1/2 of your PQ cross PR, which is square root of 2050 over 2. So if you know how to simplify this square root, then you can go ahead. If you don't know, then you can just stop it right there. That will be good enough. Okay, so this is the cross product, and the application of the cross product in terms of the area of the triangle and the area of a parallelogram. All right. Next, there are plenty of theorem, okay, concerning the cross product, okay, but because of the cross product is something that difficult, that is more difficult than the dot product, so all the theorem will be something different. For example, the first one, the A cross B is actually not the same as B cross A, but you got the extra of negative in front of it, okay, because as you think of A, okay, cross B, and using the right hand rule, your A cross B will going upward like that, okay, the A cross B using the right hand rule. But if you do the B cross A, they are different, right? So your right hand will go down like this, so this is your B cross A, okay, so they are let me just draw it like the same length, sorry, so they are about the same length, but the direction are different, okay, just pointing to a different direction. What if we got the constant C, okay, your constant C can do after the cross product, or your constant C can multiply with each one of the vector first and then do the cross product, it doesn't matter. However, for the third property, it's saying that your A cross with B plus C is the same thing like you do the multiply with the real number, so you can distribute your A to the B and you can distribute your A to the C. However, because of the first property, you cannot switch the order between A and B. It must be A first, cross B, okay? And if your A plus B, do it first and then cross the C backward like this, then your C will do the distribution backward, so it will be A cross C and then B cross C, just like this. And it is very strange that if you got three vectors, okay, if you got three vectors and then you do B cross C first, so this one is one vector, right? You do a dot product with the vector A, it is the same as you do the cross product between A and B first and then a dot product with the C. This one sometimes is called a scalar triple product, okay, and later on there will be a special meaning of a scalar triple product, okay. However, if you do the A cross B cross C, okay, this one is not the same as, like, is not associative, okay, so it is going to be A cross C and then this is a scalar, right, and then this scalar multiply with B and then it will be A dot B, this is another scalar, right, and this scalar will multiply with C, okay. So this one, don't forget, this is a dot, this is a dot, and after doing a dot product you are going to subtract these two vectors together, okay. So the last property is somewhat difficult to remember, okay. Now let us see some example, okay. The first example is about the property of both dot product and the cross product, okay. So for example, the first item, they ask that if we have A dot B equals to A dot C, then does it follow that your B and your C will be the same vector, okay. You may think about it for a minute and then you may say that, hey, maybe not. Why is that? Your A can be we can do two dimension, okay. Your A can be 1 1 and your b can be 1 0. So if you dot it together, you got the 1, and your a will be the same again, right? However, now your c is 0 1, so you got a 1 again, so they're the same, but these two, b and c, they're not equal, right? So this one is false. Okay, maybe it's not necessary that your b and your c will be the same. Okay, how about the second one? The second one will be a little bit difficult. Okay, when you have that your a cross b and your a cross c are the same, what can we conclude about the b and the c? What we can try is to move your two vectors on the left and the right, okay, to the same side like this, and then the other one equals to vector 0 vector, and then using the distributive property, okay, to pull out the a and then cross b minus c equals to a 0 vector. So what does this mean? If your two vectors cross each other to got a 0 vector, so it means that your a, it is actually parallel to b minus c. Okay, and this one I'm not so sure whether you still remember the definition of parallel of two vectors. It means that actually your a, it is equals to a k factor of b minus c. Remember this one? Okay, so that your a and your b minus c will parallel to each other. So can you solve for b? Can you solve for vector b? So because your this k, okay, of course is not 0 because your a is not a 0 vector, so your k is not a number 0. So your b can be written as 1 over k multiplied by a and then plus the c. So if you look at it this way, you see immediately that, hey, I mean, because your k is not 0 and your a is not vector 0, so this means that your b is not exactly the same as your vector c. Okay, but it will be the c plus some, you know, some vectors in the same direction as of a, okay, but have this factor 1 over k. Okay, this is the second problem. Look at the third problem. Okay, so now if your a cross b and a cross c are the same, and your a dot b and your a dot c, they are also the same, what can we conclude about the b and the c? This one motivate from your second problem. Okay, so if your a cross b are the same as your a cross c, then it means that your a cross b minus c, they are a 0 vector. Okay, let us continue a bit by using the a and the b cross b minus c as the length, and the sine theta equals to a quantity 0, right? However, because your a is not a vector 0, so the length of a is not a 0, so this means that that one can cancel, the length of a can be cancelled. Okay, how about the second condition? So it's the same as, so you got a dot b minus a dot c equals to 0, or the length of a, the length of b minus c, and cosine theta equals to 0. Again, because your length of a is not 0, so that one can be cancelled. So let us consider these two equations. So the first equation saying that your b minus c may be 0, or your sine theta may be 0. The second equation saying that your b minus c may be 0, or your cosine theta equals to 0. We can use the same angle theta because this one is the angle between a and b minus c. Okay, they are all the same angle. All right, and these two connecting by n, okay, So we using the basic logic property. So this one is equivalent to b minus c, they are the same, or you got sine theta equals to 0 and your cosine theta equals to 0. Okay, this is a basic concept of your logic. Okay, when you have the p or q and p or r, then you can pull out the p and then the or, and the q and the r will connected by n. Okay, so can we have the same angle theta and then your sine equals to 0 and your cosine also equals to 0 at the same angle? We cannot, right? So this one always false. So when you connect by or, it means that the other will be true. So if your b minus c, it is 0, the length of 0. So it means that your b minus your c, it has to be a 0 vector, and your b and your c are the same. Okay, so this problem saying that if you got only the same dot product, okay, a dot b and a dot c are the same, you cannot conclude that b and c are the same. If you got the cross product, a cross b equals to a cross c, you cannot really conclude that these two vectors b and c are the same. But if you have both cross product and dot product, they are the same like this, the b and the c must be the same vector. Okay, this is what it is. All right, so let us continue to the next problem. The next problem is actually you want to prove that your a minus b cross your a plus b, it is actually the twice of a cross b. This one you just use a distribution law. So here your a minus b can do distribute to the first a, and then your a minus b also can distribute to the second vector b here, and then you do a backward distribution. You got a cross a minus b cross a, okay, plus the a cross b minus the b cross b. All right, and because the a cross a is 0, the b cross b is 0, and the b cross a is actually the negative of a cross b. So as you have another extra negative, you got twice of a cross b. Very easy. Okay, just like that. All right, how about this one? Can you prove or disprove that your a cross b and your b always dotted together equals to 0 or not? Okay, of course, I mean the a cross b is a vector that perpendicular or orthogonal to both a and b, right? So if you talking about the b in particular, so it means that your a cross b perpendicular to b, and it's saying that if your u perpendicular to v, then your u dot v, it is 0. So it means that this one can be your u, this one can be your v, and the a cross b dot b always 0. Oh, sorry, always equals to a number 0. Okay, next is one of the most important application of the cross product as well as the dot product. Okay, so this one is the volume of the so-called parallelogram. So it's a three-dimensional object, okay, determined by 3 vectors a, b, and c, and then just extended as a parallel of each side, okay, becomes a three-dimensional object like this. To find the volume of this object, we need to find the base area multiplied by the height. Okay, so the base area we call it the A, and the height we call it the H. Can you remember the area of the parallelogram that determined by the vector B and the vector C? So we simply use the what? The cross product between B and C, right? And then you want to determine the H, okay? So here is again the right triangle with the angle theta over here. So to find the H, you can do the what? This is the right angle here, is it? So we can say the H, the length H, okay, over the length A. So the H is the adjacent, the A is the hypotenuse, so it is a cosine theta. So the H is simply A cosine theta, just like this. And then what is it? This is one vector, okay, B cross C. This is another vector A, and then you just multiply two lengths together with the cosine. So it is actually it is the A dot B cross C, right? Because if you got two vectors, let me just write down. You got U dot V, it is the length of U, the length of V, cosine theta. And because your cosine has the absolute value, so it means that you got the absolute value at your U dot V as well. Okay, so the absolute value of this dot product between A and B cross C, it is the volume of a parallel pipette determined by A, the vector A, B, and C. Okay. Don't forget that you need this always, okay, need the absolute value because the volume must be positive. And to find the triple product, so this one, don't forget that this is the scalar triple product. Okay, so to find the scalar triple product, you can do it using the determinant again. So here is your A1, A2, A3 as a component of A, B1, B2, B3 as a component of your vector B, and C1, C2, C3. This determinant will be your scalar triple product between these three vectors. Now let us try to imagine, okay, you still have your A, your B, and your C like this, but you are going to connect the A and the B and the C together like this. What will happen? Okay, so let us draw a new picture like that over here. So let's say that this is your A, this is your B, and this one is your C. And then as I told you that we are going to connect these terminate points, okay, together. So what you have is a pyramid, okay, with the triangular base pyramid, or sometimes we call it tetrahedron. Okay, the tetra means 4 and the hedron means face, so this figure has 4 faces. Okay, so what will be the volume of this tetrahedron? So you need to remember that the volume of a pyramid, okay, is simply 1/3 of a volume of a prism of the same base. Okay, so if you talk about the base, it's right here, the base is a triangular base, right? So it means that if you want to go back to a prism, it's a prism that connecting your A and your B like this. So you have your A and your B and your C like this. So it's look like a half of your parallel pipette, right? So your prism got a half of a parallel pipette, so it is A dot B cross C, okay, because this is a parallel pipette, half of them, and then 1/3 to got a pyramid. So the volume of a pyramid or a tetrahedron determined by the A, the B, and the C will be 1/6 of the scalar triple product between them. Okay. One more thing that you may need to know about the scalar triple product is that if your A, your B, and your C are on the same plane, okay, this is the plane, and your B is right here, your C is right there, and your A also on the same plane. Okay, it means that we cannot construct a parallelepiped from this kind of three vectors, right? So it's going to determine that your scalar triple product between these three vectors are going to be a 0. Okay, so if you have this one, then it means that your A, your B, and your C lie on the same plane, which we usually call a coplanar. Okay, a coplanar. All right. So if your triple product equals to 0, then these three vectors, they are called coplanar. Okay. So let us go ahead and try to look at the example. So the first one, you need to use a scalar triple product to show that these three vectors are coplanar, as I told you. So you need to find A dot B cross C, make it equals to 0 or not. If it is, then it is coplanar. So the scalar triple product between them, okay, it is simply the determinant of 1, 4, -7, 2, -1, 4, 0, -9, 18. Again, if you know how to do it very quickly, then you just do it. Okay, just go ahead. And this one, we are going to write another 2 columns, okay, so that we can have a diagonal multiply, which is -18. The second diagonal multiply, we got 0, so it just ignore it. And then the third diagonal multiply, you got 7 and 9, which is 63, and then multiply by 2, so you have a positive of 126. So the upward multiply, you got 0. The second one, you got 9 and 4, so it is 36 with negative, but it is upward, so you got 36 as a positive. And the last one, you have 8 and 18. Okay, so it is 18 and 8, so it is 4, 6, 144. So you have -144. Okay, so you add them up. What is it that you got? For the positive part, you have 162, right? For the negative part, you got 2, you got 6, you got -162. So you add them up to got a scalar triple product as 0. So because they are 0, then your A, your B, and your C lines on the same plane, or it is coplanar. They use R. They are coplanar. Okay, so they are on the same plane, just like that. Right. Now, the same thing, you need to use a scalar triple product again to verify that these three vectors are coplanar. Okay, so you should be able to do it by yourself already, right? So to check your A dot B cross C using a determinant, okay, the first one is 2, 3, 1, and then your B is 1, -1, 0, and your C is 7, 3, 2. Okay, So you find whether it is equals to 0 or not. If it is, then it is coplanar. If not, then it's not coplanar. Okay, so this one we would like you to try it by yourself. So next we are going to use again the scalar triple product to determine that these 4 points lie on the same plane. So just think of it a little bit, and then just think of everything as originate from P or initial from P, and then your P go to Q, your P go to R, and your P go to S. Okay, so what we need to find is a PQ, which is a Q minus a P. So your Q is 2 and 1, 4 and 0, 6 and 1. Okay, or it is 1, 4, 5. How about your PR? Your PR is R minus P. So your R is 3 and the P is 1, -1 and 0. And then a 2 and 1. So you got a 2, -1, 1. And your PS will be S minus P. So your S is 6 and 1, 2 and 0, 8 and 1. You got a 5, a 2, a 7. And what you need to determine is your scalar triple product between these 3 vectors, which is PQ, PR, and PS. Okay, which is again a determinant of 1, 4, 5, 2, -1, 1, 5, 2, 7, and see whether it is equals to 0 or not. If it is, then they are coplanar. Then if it is coplanar, then it means that these 4 points will be on the same plane. Okay, but if it is not, then it's not on the same plane. Okay, that's it. But you really need to calculate and get yourself used to a calculation of the determinant. Okay, so I'll let you guys do this problem by yourself. If you got any difficulty, please let me know, okay, when we see each other. So we are going to stop this video clip at this point, and then the next one still in chapter 3, but we are going to start to look at the so-called equation of the lines and the equation of the planes. So we'll see you then. Bye bye.